Okay, Brian, when you're ready.
Perfect. Thanks for the introduction, Giuseppe. First, I wanted to say how sorry I am and how sad I am that we aren't able to do this in person and that I can't meet all of you face to face and discuss Condor-CE in a conference setting. As Giuseppe mentioned, I am the OSG Software Team Manager. I work out of the Center for High Throughput Computing at the University of Wisconsin-Madison. The Center for High Throughput Computing also distributes the entire HTCondor software suite. Next slide, please. So before diving into the details of Condor-CE, it's always a good idea to take a step back and think about how the CE fits into the entire research computing endeavor. So on the left here, you have your user submit. This is where the actual researchers interact with the grid. On the bottom, you have pilot factory, generally managed by some virtual organization. And on the right, you have a site. Next slide, please. The users will submit their research payload jobs to their own submit host that they have access to. Next slide, please. And the pilot factory recognizes this job pressure at the user submit side and submits pilot jobs to the CE. And you'll notice that here I have labeled the pilot jobs themselves as resource allocation requests and the CE as a compute entry point rather than a compute element. This is some of the language that we have found is easier to introduce to brand new sites to the grid to help them understand the actual usage of these various services and jobs. So these pilot jobs end up running on the local batch system after sitting in the queue, and they start up some worker node software. Next slide, please. And then they will contact the user submit side, or they'll call back to it. And then the user jobs themselves will match to these new resources that have magically appeared to them. And then they will begin running on the underlying resources at the remote site. Next slide, please. So what exactly is a CE? As I mentioned, we call it a compute entry point at the CHTC. And this serves as the door that forwards the resource allocation requests onto your local compute resources. And to be able to provide this, it needs three things. It needs to expose a remote API to accept the remote resource allocation requests. It needs to provide authentication and authorization of the remote clients. And it needs to interact with the underlying resource layer, the batch system. A CE host is made up of a thin layer of CE software installed on top of the software that submits to and manages jobs on the local batch system. And one reason that we decided to land on the resource allocation request name for pilot jobs is because this more easily differentiates between pilot jobs and the user payload jobs. And the CEs themselves are designed to support the former, the resource allocation request, and is generally not intended for direct user submission. Next slide, please. So this is what it will look like on a CE host. The remote sides, the pilot factory, submits the pilot job to the CE host. The CE host then performs its authentication and authorization, and then transforms that remote pilot job into something that the local batch system can understand. Next slide, please. So before we get into Condor-CE, you need to know a few Condor basics. The most important Condor daemons to be aware of are the master, the schedD, the collector, and the grid manager. These are all daemons that will run on various hosts in a normal Condor pool, but we reuse them for the Condor-CE. So the master is responsible for starting and stopping all the other Condor daemons on a host. The schd accepts jobs and stores job state information. You can think of this as the job queue. The collector stores information about all the other Condor daemons. And the grid manager submits jobs to remote scheds, non-Condor batch systems. It also can handle things like private clouds and that sort of thing. You also need to know about class adds. Class adds are what we call the lingua franca of describing entities in Condor. All the daemons have associated class adds. Jobs are described as class adds. Deep down security sessions between daemons and clients are described as class adds. Class adds are schemaless, and they're made up of a bunch of key value pairs. It's a declarative language with a lot of rich expressions, and the major use case they have is they're used to compare requirements between two entities. So a job may have specific resource requirements, and a worker node would then advertise what resources it has and its own requirements. Say a worker node will only run Atlas jobs. Then it can express that in its own requirement statement. Next slide, please. The Condor team maintains two different versions, a new feature version and a bug fixed version at any given time. These are available in the development and stable Yum repositories, respectively. The current versions or the current series are Condor 8.9 for the new features and Condor CE 4. We actually just released a new version of Condor CE yesterday, so it should be, I think, Condor CE 4.4.0. And then the bug fix release series are Condor 8.8 and Condor CE 3, and we also released, I believe, 3.2.2. And these are just kind of the highlights of the Condor basics that you need for this talk. For more information on these basics, you can visit our YouTube channel, where that is very much focused towards running your own Condor pool, but there is a video about class adds and learning about class adds. And then also the class add documentation is very useful. Next slide, please. So Condor CE is Condor configured as a compute entry point. It uses all the same Condor binaries, the daemons and the client tools. It uses the same class add description language and the configuration, same configuration language to provide the remote API that a compute entry point needs. If you're familiar with Condor, there are all the relevant Condor tools for a Condor CE are wrapped to use the Condor CE configuration to differentiate between Condor CE and Condor config living on the same host. So your Condor Q command, Condor status, Condor submit has Condor CE equivalents, Condor CE status, Condor CE Q, Condor CE submit. And to differentiate between the local Condor daemons, there is a separate Condor-CE service. Next slide, please. So what this may look like on your Condor CE host or your CE host with a Condor CE and a Condor batch system, there are two sets of the Condor daemons. So that means that there are two sets of configuration, and they live in HTCondor-CE config D and HTCondor config D. And these daemons write to two different sets of logs, varlog Condor CE and varlog Condor. So on the right, you'll see some PS tree output. The top one is your Condor pool. This installation is an example of a mini Condor, which includes all of the daemons necessary to run Condor on a single host. And the bottom is the set of Condor CE daemons. For a quick and easy way to identify the Condor CE or to differentiate it between the two different sets is that the Condor CE has a Condor job router daemon, and we'll go into that in more detail later in this talk. Next slide, please. So by default, Condor CE provides GSI authentication and uses Condor security levels for its authorization. Condor-CE 4, the one that's currently available in the development repository, iterates on this default authentication model. GSI authentication is still supported, but SI tokens or WLCG JSON Web Tokens are preferred if presented by the client. And you have a new enough version of Condor itself, of the Condor binaries specifically. And then in previous versions of Condor, the CE daemons on the same host would all authenticate with each other through GSI, through the CE's host cert, which was a bit heavyweight, but was the only way that we could do it at that point. So with Condor-CE 4, we've simplified the authentication between daemon hosts, and they use local file system methods of performing authentication. So if you're doing an upgrade from an older version of Condor-CE to Condor-CE 4, this is something that you may notice. Next slide, please. And to complete the final requirement for a CE, Condor-CE supports interaction with multiple batch systems. It interacts with Condor batch systems directly. It can also interact with Slurm, PBS Pro, Torque, SGE, and LSF batch systems. And then it can do all of the above over SSH instead of being on the same host. Non-Condor batch systems and SSH submissions are supported through the HTCondor Grid Manager daemon and the Batch ASCII Language Helper Protocol, or the BLOP. For those of you coming from the Cream CE, I believe that you are very familiar with the BLOP already. The HTCondor-CE's usage of the BLOP is slightly different, but it still uses more or less the same code. Together, the Grid Manager and the BLOP take the routed job and further transform it into your local batch's job description language. Specific attributes in the job class add result in batch system specific directives. For example, the batch runtime attribute will result in the sbatch --time directive for Slurm batch systems. Together, the Grid Manager and the BLOP are also responsible for querying the local batch system to pass along job state updates from the local batch system back along the chain to the CE instance of the job, and then all the way back to the remote submitter. Next slide, please. And earlier I mentioned the job router daemon. The job router is responsible for taking a job, the initial incoming grid remote allocation resource request, creating a copy and changing the copy according to a set of rules. So when running a Condor batch system, this copy is inserted directly into the local batch's SCED. Otherwise, the copy is inserted back into the CE SCED. And each chain of rules is called a job route and is defined by a class add in the Condor-CE configuration. And job routes are intended to reflect a site's local policy. Once the copy has been created, attribute changes and state changes are propagated between the batch system and the source jobs. Next slide, please. So when you start a Condor-CE, this is kind of how the startup process looks like. Using whatever init system that you prefer, you start the Condor master. In turn, the Condor master starts the SCED, collector, and job router daemons. And then the SCED, master, and job router all send their class adds describing themselves to the collector. And so when you run the Condor-CE status-any command, you should see at least these 4 daemons. At the bottom here, you'll also see a submitter daemon. This describes or not the daemon, it's a submitter add. This describes the user and usage of jobs in the CE. Next slide, please. So this is what it would look like for a Condor CE on top of a Condor batch system, the resource allocation request workflow. So the incoming pilot job is submitted to the CE SCED-D. The CE SCED-D performs the authentication and authorization to see if that the remote client has permissions to run jobs at your site. And the job router then picks up this initial grid pilot job and transforms it to a local job submitted directly to your local SCED-D, or then it will your Condor central manager, specifically the negotiator, will look at the requirements of that job and compare it to what is currently available in the Condor pool. Next slide, please. For the Condor CE and non-Condor batch system situation case, this looks slightly different. Since there's no local batch system SCED-D, jobs are routed back into the CE SCED-D as grid universe jobs. And these grid universe jobs spawn the grid manager daemon, one per user, with log files that live in var log Condor CE grid manager log.user. And this case requires a shared file system across the cluster, specifically the Condor CE spool directory. And this is necessary to transfer files that the pilot job need from the submit host or the head node to the worker node. Next slide, please. So this is what it looks like for the non-Condor batch system case. It's very similar, except that the initial pilot job that is picked up by the job router is transformed and put directly back into the CE SCED-D, starts the grid manager, and the grid manager, using the BLOP, uses local batch system client tools to submit that job. So QSub for PBS, Torque, or SBatch for Slurm. Next slide, please. You can combine these two together, and there are a few sites that do this. So what happens in this case is the same song and dance for the pilot job to the job router. Then the job router, no matter what kind of job it is, submits the routed job to the local SCED-D. And from there, the local SCED-D, depending on whether it's intended for the Condor batch system or the non-Condor batch system, will make a decision. If it's a Condor job, then it will perform the Condor negotiation with the central manager. If it is a non-Condor batch system job, then the SCED-D will start a grid manager daemon, and that grid manager will then submit that job to the non-Condor batch system. Next slide, please. I mentioned the Condor CE over SSH, supporting all of the other batch systems. This uses Bosco, and Bosco is basically a remote Condor and BLOP installation on the remote side that you will be SSHing into, or that the Condor CE will be SSHing into on your behalf. This requires SSH key-based access to an account on a node that can submit and manage jobs on the local batch system. And on this node, there needs to be a shared home directory across the cluster for pilot job transfer, file transfer. This is analogous to sharing the spool directory in the non-SSH case for non-Condor batch systems. So the Open Science Grid makes a lot of use of this for Condor CE over SSH to offer Condor CE as a service for small sites. And we call this offering the hosted CE, and it can support up to 10,000 jobs concurrently. Next slide, please. So this is what it'll look like. It's very much the same song and dance similar to a non-Condor batch system setup, except that grid manager will start up an SSH session to the specified head node, where then the blob will handle the local job submission. Next slide, please. So what do you actually need to install a Condor-CE? Condor-CE works on TCP port 9619, so that needs to be open. For non-Condor batch systems, I've already mentioned that there needs to be a shared file system for the spool directory. CA certificates and CRLs need to be installed in Etsy Grid Security certificates for the GSI authentication, as well as VO information installed in Etsy Grid Security Vomister. For jobs that are submitted to the CE, they are mapped to local Unix accounts, depending on the credentials that they present. You need to ensure that these mapped users exist on the CE and across the cluster. Hardware requirements for CE are fairly minimal, just a handful of cores. Condor backend should plan on 0.5 meg of RAM per job. This, I believe, is the recommendation just for Condor submit nodes in general. So for example, our hosted CEs run on 2 virtual CPUs and 2 gigs of RAM. Condor and Condor CE are very much subscribed to the idea of spreading out horizontally. So if you need to, if you have a CE that seems to be receiving a lot of undue pressure, then the solution is to stand up another CE. Next slide, please. So normally the configuring Condor-CE section is a whole talk on its own, but I'll try and cover the highlights and link to further information if I can't get into the details. So first you need to configure authentication and authorization on the CE. Well, namely the authentication. Authentication is configured through the Condor-CE unified map file. There is one mapping per line with the format of the authentication method, the authentication name, and then what user that the credential is mapped to. The authentication names support Perl compatible regular expressions, and the mappings, the credentials are mapped to the HTCondor principal based on which one matches the regular expression first. The HTCondor principals themselves determine authorization levels. So anything that ends in the @daemon.htcondor.org is authorized as a daemon. You generally don't want to mess with this too much because we provide the defaults for this, and if there are additional daemons that you need to run, we generally provide that in packaging with the proper configuration. Anything that ends in @users.htcondor.org are authorized to submit jobs. There is a special auth name, GSS assist grid map, and this is a special value that tells Condor-CE to call out to another service for user mapping. So if you're using LC Maps or Argus, then you'll need to use that and update some files to be able to point to the proper call out. And that's all documented in the link. Next slide, please. You also need to configure Condor-CE for your batch system. For Condor batch systems, you need to specify the location of your local batch schedD, collector, and spool directory. For the non-Condor batch systems, you need to configure the blob and configure how you will share the CE spool directory across your batch system. And there's more information and details at the link here. Next slide, please. For the job router configuration, this is where you're going to be spending probably most of your time because this describes your site policy. Job routes themselves specify which jobs to consider and how to transfer them. As mentioned, each route is described by class ads. Job routes are constructed by combining each entry in the job router entries configuration with the job router defaults. And there's an entire page for various things that you may want to configure your job routes to do, to set a specific queue, to set a counting group, to set default, CPU, memory, etc., those sorts of requirements. Next slide, please. So this is an example of two job routes for our ce1.opensciencegrid.org CE. And this CE accepts WE&MR jobs from Dirac. And there are two routes here. This CE stands in front of a Condor pool. So there are a couple of required attributes, the name and the target universe for, this is required for a Condor batch system. And then you can see that the first route has a requirement that if a job comes in that says that COVID-19 is equal to true, that job should match this route. And in that case, then it sets the project name attribute on the routed job to the string COVID-19_WE&MR. And then the next route doesn't have any requirements, so all jobs that don't meet the first route's requirements will match to this. And since the CE is only accepting WE&MR jobs, we just default that to set the project name to WE&MR. So the job router is responsible for doing the matching between the different routes. And as I mentioned, each job is compared to each job's route's requirements expression. And this is default. This is true by default, so it'll match all jobs. And the order by which job routes are compared to the jobs is specified by the configuration job router route names. To use round-robin matching behavior, which is the old default, you will want to set the following configuration in your CE configuration. It's the job router round-robin selection configuration knob. Next slide, please. In addition to matching, I mentioned that job routes also do transformations. And there are special job route functions that are used to perform these transformations to affect changes in the routed jobs. And there are 4 of these functions: copy, delete, set, and eval set. Copy takes an attribute from the original job, copies it to the routed job under the different name. So in the routed job, in this case, in this example, we'll have original foo set to the value of the foo attribute in the original job. You can also delete attributes from the original job, from the routed job. The original job will still contain this attribute, but the routed job would not. The set function will set an attribute in the routed job to a value or some sort of expression. And then the eval set will do the same thing, except it will evaluate the expression given immediately in the context of the original job ad. All right, so CEs don't stand alone. They have to integrate with the rest of the grid. So next slide, thank you. First off, it needs to accept jobs from pilot factories. Production Condor-CEs in the US have all been proven to work with Dirac, Gladden WMS, and Harvester. One note about Dirac that I've gotten a lot of questions about recently is that Dirac pilots are left in the job queue for up to 30 days. This is just by design. Condor-CE 4.4.0 adds the optional completed job expiration configuration so that you as the CE site admin can control how many days the completed jobs may remain in the queue if you want to shorten or lengthen it based on discussion with your VO that is running Duroc. SciToken and WLCG JSON Web Tokens have been tested by the Glidden WMS and Harvester developers with Condor-CE. And Condor-CE also offers auditing of user payload jobs. This occurs when the pilot is configured to advertise their start D information back to the site Condor-CE collector. Next slide, please. APEL Accounting. So we have an RPM for Condor-CE and APEL and uploading APEL records. The RPM contains configuration, scripts, and services for generating APEL bash and blah records. The scripts key off of configuration that are set on each worker node for the scaling factor. Then they write their batch and blah records to the APEL output directory. Currently, this implementation only supports Condor-CE with the Condor batch system. Follow the link for details on how to configure this. Next slide, please. We also have a package for BDII integration. This package contains the script that generates the LEIF output for all the Condor-CEs at a site, as well as information about the underlying Condor batch system. This only supports Condor batch systems. And you can visit the link on details for how to configure that. Next slide, please. We also offer something called the Condor-CE Central Collector. And this is a simple information service built on existing Condor features, the Condor view, and the fact that the class ads are schemaless. And we use this in the OSG to report some useful grid information of all the CEs, like contact information, the various access policies, what resources can be accessed, and some other important debugging info for our central operations team. And each Condor-CE in a grid can be configured to report information to one or more Condor-CE central collectors. We have a couple for testing and for backup purposes. And we just finished the installation documentation for this. So if a central grid operations team is interested in installing this, they can visit this documentation. Next slide, please. So this is the sort of information that we provide, and this is kind of just the default output. So you can query the OSG central collector and see all the CEs that are reporting to it, the batch system, CE versions. If you want to if you're really excited, you can pass the -L option to this command and get the entire class ad for each and every CE Skenti in the OSG. Next slide, please. Alternatively, you can pass the -JSON option, which provides the class ad in JSON format. Next slide, please. And I just did a quick analysis yesterday of the CEs that are all reporting to our central collector. We have about 117 production CEs reporting. Most of them are in front of Condor pools, but about a third of them are in front of Slurm systems, and there's a smattering of PBS and SGE. Next slide, please. So why should you use Condor-CE? If you're using Condor for your batch system, I think it's pretty straightforward. You have one less software provider. It's the same thing all the way down the stack. Condor has an extensive feature set, which is easy to take advantage of with a Condor-CE. For example, Condor supports submitting container jobs through its Docker universe. But even if you don't have a Condor-CE, there are a few advantages. It can scale well. It has a declarative, it uses a declarative class ad based language, but there are disadvantages. Outside of PBS and Slurm, the support there is a bit finicky. And if you're not already familiar with class ads, then this can be a bit of a learning curve. Also, if you need APEL and BDII, we do not support Condor-CE with the non-Condor batch systems for those. Next slide, please. So what's next on our roadmap? We're working on a couple of big features. The Condor-CE registry is something that we're testing out in the OSG. It's a service that lives on the central collector, and what this will do is it'll facilitate token exchange between the site Condor-CEs and the pilot factories, and the end goal here is to eliminate the need for the site Condor-CEs to have host certificates altogether. We also worked with the Condor team on greatly simplifying the job route configuration language. The set, copy, eval set, and delete functions that I mentioned earlier can interact in very confusing ways in the current world order. Basically, all the copy functions happen first, then delete, then set, and eval set, which is not something that many site admins expect. And so the new way will basically evaluate the expressions in the order that they are, evaluate the functions in the order that they are written. And further on the OSG side, we're working on containers and Helm charts, and we're still exploring this on the Condor side. But if you guys are interested in container and Helm chart development, then that could certainly accelerate that on our roadmap. Future events, we're going to hold Condor-CE office hours in July. The date and time are to be determined, but will be announced through the HTCondor.org website and our mailing lists. And then European Condor Week, there will be, I believe, one day dedicated to Condor-CE, or at least mostly dedicated to Condor-CE. That will be happening in early September. Next slide, please. So if you've decided to get started with Condor-CE, it's available as RPMs through the HTCondor Yum repositories, and you should start installation using the documentation available at HTCondor-CE.org. Next slide, please. In conclusion, I wanted to thank EGI in general for the opportunity to talk about Condor-CE today, especially Catalan and Giuseppe for all their help over the past couple of months. And I wanted to let you know that the Condor team is happy to discuss anything related to Condor-CE through our community mailing list. Or if you'd prefer, you can contact the Condor team directly in a more private way using the condor-admin@cs.edu email. That's all I had. So I believe we can start our Q&A, and I can stay until, I guess it's 5 p.m. Geneva time.